Welcome to section 5.5, the fundamental theorem of calculus. Our goal today is to use the fundamental theorem of calculus to solve problems. So our theorem is, if f is a continuous function on an interval from a to b, and capital F represents an antiderivative of f, then the integral from a to b of our function with respect to x is the antiderivative at b minus the antiderivative at a. The definition of the average value of a continuous function of f over the interval from a to b is 1 over b minus a, integral a to b of f of x. So those are the things we're going to apply today. Let's use them. In problems 1 through 7, evaluate the integrals. The integral from 2 to 6 of 8x cubed plus 3 dx. So we'll take the antiderivatives. We have 8x to the 4th over 4 plus 3x over 1. And we're evaluating it from 2 to 6. So we'll have the reduced 2x to the 4th plus 3x, again evaluated from 2 to 6. What this means is we'll plug in 6, 2 times 6 to the 4th plus 3 times 6, and then we will subtract 2 times 2 to the 4th plus 3 times 2, as our definition says. So this will give us 2,610 minus 38, which is 2,572. Okay, the integral from 0 to 5 of 2e to the x dx. So we take the antiderivative, 2e to the x, we're evaluating from 0 to 5, which gives us 2e to the 5th minus 2e to the 0. 2e to the 5th minus 2, e to the 0 is 1. And so this will give us about 294.83. Integral from 7 to 7 of 2x cubed plus 5x squared minus x plus 27 dx. Now notice our lower and upper limits of the integration are the same value. It's going from 7 to 7. And when that happens, our integral is 0. Because remember, the integral is telling us the area under the curve. If we're looking only at 7, there is no area. The integral from 13 to 22 of 5 over square root of x plus 3 dx. Let's start with rewriting. We have the integral from 13 to 22. I have 5 times x plus 3 to the negative 1/2 power dx. And now we can take the antiderivative, 5x plus 3 to the 1/2 over that 1/2. We're evaluating from 13 to 22. We can reduce this. We'll have 10 x plus 3 to the 1/2 from 13 to 22. And so we'll have 10 times 22 plus 3 to the 1/2 minus 10 times 13 plus 3 to the 1/2. This will give us 10 times 5 minus 10 times 4, and so we end with 10. The integral from 0 to 1 of 2x cubed times 3x to the 4th plus 2 all raised to the 6th dx. We'll solve this problem using the substitution method, and we'll start with u equals 3x to the 4th plus 2. So du is 12x cubed dx, which will let us write as 6 times 2x cubed dx. So let's rewrite in terms of u. We'll have 1/6 integral from x equals 0 to x equals 1 of u to the 6th du. Taking our antiderivative, we have u to the 7th over 42, because that 1/6, from x equals 0 to x equals 1. And we're clarifying that because we're using u's right now. We don't want to forget and plug this into the u. We substitute back in our x values. So we have 3x to the 4th plus 2 raised to the 7th over 42. And we're evaluating from 0 to 1. So we've got 3 times 1 to the 4th plus 2 all to the 7 over 42 minus 3 times 0 to the 4th plus 2 all raised to the 7 over 42. And that will give us about 1,857.07. Integral from 1 to 2 of 3x squared minus 2x plus 5 over x cubed minus x squared plus 5x minus 3 dx. We'll solve by using substitution. Let u equal x cubed minus x squared plus 5x minus 3, and du will equal 3x squared minus 2x plus 5 dx. Let's rewrite it in terms of u. So we've got the integral from x equals 1 to x equals 2 of 1 over u du. Our antiderivative is the natural log of u from x equals 1 to x equals 2. So we've got natural log of x cubed minus x squared plus 5x minus 3. And we're evaluating from 1 to 2. This will give us the natural log of 2 cubed minus 2 squared plus 5 times 2 minus 3 minus the natural log of 1 cubed minus 1 squared plus 5 times 1 minus 3. Simplifying this will be the natural log of 11 minus the natural log of 2, which is approximately 1.7. Okay, the integral from 1 to 2 of 3x times the square root of 6x squared plus 1 dx. We'll solve this using substitution. So let u equal 6x squared minus 1. Du will be 12x dx, which we can write as 4 times 3x dx. So let's rewrite in terms of u. We have 1/4 the integral from x equals 1 to x equals 2 of u to the 1/2 du. And so we'll have the antiderivative, 1/4 times 2/3 u to the 3/2 du, evaluated from x equals 1 to x equals 2. Plugging our x's back in, we have 1/6 times 6x squared plus 1 to the 3/2, going from 1 to 2. And so we'll have 1/6 times 6 times 2 squared plus 1 to the 3/2 minus 1/6 times 6 times 1 squared plus 1 to the 3/2. Simplifying these, we'll have 125/6 minus the square root of 343/6, which is approximately 17.75. In problems 8 and 9, find the average value of the function over the given interval. So now we're using the average value. F of x is 8x cubed minus 16x plus 4, and our interval is from 1 to 6. Remember, we're using 1 over b minus a times the integral from a to b of f of x dx. And so we'll have 1 over 6 minus 1 times the integral from 1 to 6 of 8x cubed minus 16x plus 4 dx. This will give us 1/5 times 2x to the 4th minus 8x squared plus 4x evaluated from 1 to 6. Plugging those in, we'll have 1/5 times 2 times 6 to the 4th minus 8 times 6 squared plus 4 times 6 minus 2 times 1 to the 4th minus 8 times 1 squared plus 4 times 1. This will be 1/5 times 2,328 minus a -2, giving us a final answer of 466. That's our average value of this function over that interval. G of x equals 2e to the negative 0.3x. Our intervals from 0 to 10. We'll solve this using substitution. Let u equal negative 0.3x and du equal negative 0.3 dx. So let's begin by rewriting in terms of u. So we'll start with our formula, plugging it in, 1 over 10 minus 0, integral from 0 to 10 of 2e to the negative 0.3x dx, which would give us 2 over we've got the integral from x equals 0 to x equals 10 of e to the u du. This will give us the antiderivative of negative 2 over 3 times e to the u, evaluated from x equals 0 to x equals 10. Putting our x back in, negative 2/3 times e to the negative 0.3x from 0 to 10 would give us negative 2/3 e to the negative 0.3 times 10 minus e to the negative 0.3 times 0. We'll have negative 2/3 times e to the negative 3 minus 1, which is approximately 0.63. The total cost in dollars of manufacturing X units of a product is C of X equals 50,000 plus 400X. Find the average cost per unit if 400 units are produced, and find the average value of the cost over the interval from 0 to 400. Okay, so let's start with part A. We're finding C bar. And remember that is C of X over X. So this is going to give us 50,000 plus 400X over X, which we could also write as 50,000 over X plus 400. So if we want to know the average cost, if 400 units were produced, we're looking for C bar at 400. So we'll have 50,000 over 400 plus 400, which will give us 125 plus 400, which is 525. So the average cost for 400 units is $525 per unit. Now let's find B, the average value of the cost over our interval. So we'll be using 1 over b minus a times the integral from a to b of f of x dx, which is going to give us 1 over 400 minus 0 times the integral from 0 to 400 of 50,000 plus 400x dx. This will give us 1 over 400 times 50,000 x plus 200x squared evaluated from 0 to 400. If we evaluate, then we have 1 over 400 times 50,000 times 400 plus 200 times 400 squared minus 50,000 times 0 plus 200 times 0 squared. Now we have 1 over 400 times 52 million, and that gives us 130,000. So the average value of the cost will be $130,000. A company manufactures a product and research department produce the marginal cost function. C prime of x equals 300 minus x over 4 from 0 to 800, where C prime is in dollars and x is the number of units produced per month. Compute the increase in cost going from a production level of 400 units to 800 units. Set up a definite integral and evaluate it. Okay, let's start with our integral from a to b of c prime of x dx, which would be, we're going from 400 to 800, and c prime is 300 minus x over 4 dx. So our antiderivative will be 300x minus x squared over 8, evaluated from 400 to 800. And so we'll have 300 times 800 minus 800 squared over 8 minus 300 times 400 minus 400 squared over 8. Those values are 160,000 minus 100,000. So we have 60,000. We'll write the increase in cost going from 400 units per month to 800 units per month is $60,000.